All right, here's the solution to the warm-up problem. So we're given W is equal to Z minus sine XY. We're given these things for X, Y, and Z, and we're asked to find dW dt. We're asked to do that in two ways. First, we're asked to use the chain rule, and second, we're in this case, the three-variable chain rule. And then the other way is we're just plug these in and take the derivative with respect to t. All right, and obviously those two approaches need to give the same answer. So let's start with the chain rule. And I didn't talk explicitly about the three-variable chain rule, but it's very similar to the two variables. So it looks like this: dW dt is equal to, so W is a function of X, Y, and Z. So what we're going to do is we're going to have three different partial derivatives multiplied by three different whole derivatives. What do I mean? dW dt is equal to the partial of W with respect to X times dx dt plus the partial of W with respect to Y times dy dt. This is what we had for our two-variable chain rule. And then we just add on the partial of W with respect to Z times dz dt. All right, and now it's just a matter of evaluating all of these things. All right, so dW dx, the partial derivative of W with respect to X, is just going to give me negative cosine xy times y, because I'm treating y as a constant. So I get negative cosine xy, take the derivative of what's inside, and I just get y. And that's times dx dt. Plus, all right, now it's the same thing. I'm going to get a very similar answer when I take the partial with respect to y, because this is symmetric, right? X and y they're interchangeable, meaning that when I take this, I get negative cosine xy times x, because when I take the derivative of xy with respect to y, I just get x times dy dt. All right, and then I take the derivative of this with respect to z, which is just 1, right? Z doesn't appear here. I treat these as constant. That goes away. I just get 1. Then I get times dz dt. All right, well, here are my functions. So now I need to plug them in. So I get that this is equal to negative cosine xy is t log t. So cosine t log t times y, which is log t, times dx dt. Well, if x is just t, dx dt is just 1. Plus, then I get the same thing, negative cosine t log t. And now I multiply by x, so now I get a t. And then dy dt is just 1 over t. Plus, I'm going to run off the page. Let me erase and then continue working. All right, so I just moved this line that was beginning to get cut off. I moved it up here. And we were looking at this last term. So we had 1 times dz dt, so 1 times, so we're taking the derivative of this with respect to t, which is just the same thing, because e to the t minus 1, I can write that as e to the negative 1 times e to the t. Now when I differentiate this, I just get e to the t times e to the negative 1, or e to the t minus 1. Right, another way to think about it is I take the chain rule here. So I differentiate e to the blah, and I get e to the blah, which is the derivative of that, times the derivative of this thing, which is just 1. All right? Okay, so now I just need to clean things up a little bit. Let me erase this. So I need to clean things up a little bit. What I'm going to do is I'm going to bring this guy all the way over here, e to the t minus 1. Plus, you can see I'm going to get a negative cosine t log t. I'm going to factor that out, and then I'm going to get a times, here I have a log t, and here I have a times t times 1 over t, so that's, plus 1. So this is my final answer. I get that this derivative dw dt is equal to e to the t minus 1 plus negative cosine t log t times log t plus 1. All right, that's one way. Now what I need to do is I need to plug all of these things in and then differentiate directly with respect to t. All right, let me erase to give myself some room, and then we'll do that. Okay, given myself some room, here's what we found with the chain rule, and we're going to compare that to what we get from direct substitution. So we get d by dt, z is equal to e to the t minus 1 minus sine x times y is t log t. Okay, so this is what we need to differentiate if we're going to do it directly. Well, we've already done this derivative. That was just e to the t minus 1. And this one is going to give me negative cosine t log t times the derivative of this, which is log t plus, right, so I'm doing the product rule. So I took the derivative of the first one, which was 1 times log t. Now I take the derivative of t times, I take the derivative of this, which is 1 over t. And so I get e to the t minus 1 minus cosine t log t times log t plus 1. And if you look, that's exactly what I got by the chain rule. So this is direct. Okay, so that's how you solve the problem.